Hello, hi, grade 12s. How are you? A little baby tells me that you have been waiting anxiously for this show. Now, today we are doing life sciences and it's 6 p.m. and we are doing life sciences. Hope you're going to enjoy the show. Hope you got all your pens and papers ready for the show. And remember to visit our website, which is learnextra.co.za/live. Or simply go to our Facebook page, which is facebook.com/learnextra, and like our page. If you didn't like it yet, where have you been? And for those who have been in a page with us, you know what to do. Ask those questions, those queries, and help each other out on the page. Now, helping us on this today's show is the awesome life science guru. It's Islam. How are you, Aslam? How are you, sir?
Are you, Seppo, I'm fine. Are you using the word guru because I'm Indian?
No, because
Sure.
I respect
Otherwise,
you.
I'll call you racist.
I'm sorry. That's Aslam himself, guys. You know him.
Hi, guys.
Okay, guys, enjoy the show.
Welcome to Mindset Live Extra, guys. And we have extra today. We have Seppo with us. And I'm hoping you are energized and ready to rock and roll. We come to the most controversial part of evolution, and that is human evolution. But remember, when we started evolution, I told you that we are learning evolution as a theory. Nobody's asking you to change your belief. Not even the examiners are asking you to change your belief. When you are writing about what the scientists say about evolution, and not whether you believe it or not. Nobody's going to ask you also. You cannot be penalized for believing or not believing in that and changing your religious beliefs. Okay? So let's get the show rocking. What do we do today? First of all, we're going to consider those aspects of human evolution as follows. We want to see a phylogenetic tree. Remember, we spoke about phylogenetic tree already in DNA, and we spoke about it before, a phylogenetic tree, commonly called family tree. Remember in an exam, when they ask you this question as a terminology question, you cannot write family tree. It is not accepted. All right? This is a phylogenetic tree to show ancestry, not just who your grandparents are, but to show ancestry in terms of the origin of species. That's what we use a phylogenetic tree for. And why we're using it here is to show our place in the animal kingdom. Where do we fit into this whole picture, according to scientists? Also, we go a little further to see what characteristics we share with other primates. And we go further to see what makes us different, what makes us unique from others. We then want to see progressive evolution of these features that we are talking about, the similarities and the differences. Progressive features, what the hell does that mean? It means, according to evolution, things started primitive and became modern. So progressive would mean from the oldest to the current. What happened? How did these changes, or what changes took place as such? That's what we are talking about there. And the contribution of African fossils, mainly. We look at a lot of fossils, but our concentration is more on those fossils that were found in Africa to the understanding of human evolution. In other words, we found these fossils here. Good. So, scientists are saying, we found these fossils here, and this is what it means in evolution. Where do these things fit in? Jigsaw puzzle. You're busy fitting the parts together. You can't just put any piece anywhere. You've got to put the pieces that fit into each other together to make this big concept, the puzzle itself. So the same thing we're talking about here. Fragments. A fossil was found in Tanzania. A fossil was found in Ethiopia. A fossil was found in South Africa. Kromdraai, etc. Taung. Everywhere fossils were found. But how do these fossils increase or decrease the scientists' understanding of the development of humans? Then we go to what is called the out of Africa hypothesis. And we're also trying to, if we get that far, to discuss evolution in present times. Now, at this juncture, I want to pause. And I'm going to ask a question. And I want you to pose this, the answer, post. I'm posing the question. You must post the answer on the Facebook page. I want to know from you, and I want to see who's the person that answers first. We're going to announce your name here on the show. Last week, right at the end of the show, I made a very big mistake. Not so big, but it's a mistake nonetheless. I'll give you a hint. We were talking about natural selections, and we were talking about viruses. Okay, so HIV was the question that was posed to me. All right, I want you to figure out if you remembered from last week already, if you were watching last week. So I'm checking whether you're watching on one hand, and at the other hand, I'm checking whether you are sharp enough. I picked it up the minute I left studio, and the unfortunate part is I can't rewind. I can only do it the next week. So I'm going to correct that today, but I'm going to leave that till the next session. That means after break, I'm going to check what you tell us, and we'll take it from there. Lastly, if we can, we'll consider alternative explanations to evolution. In other words, the creationist theory and the intelligent design as explanations. We also can look at arguments against evolution if we have time. But otherwise, we will do that when we do revision. The question now is this guy your ancestor? Sepo, is that your ancestor?
You
think? Grandfather, great-grandfather?
Great-great-great-grandfather.
You think so?
Yes, I think
All right. When we finish today,
yes,
you're going to tell me in the last segment whether you agree with the statement you're making now. Sebo is telling us that he agrees that this could be his great-great-great-grandfather because it's one of our ancestors, according to Sebo. But I want you to listen carefully, Sebo, and you tell me at the end of this show today whether you agree with that statement or not.
Okay, I'm with you on that.
You're going to tell me, right?
Yes.
Okay, in some... There's Sepo,
Yeah.
a little better view.
Yes.
Huh? Or are we there?
Oh my word.
Striking similarities, don't you think, guys? Huh? The DNA difference, Sepo, between humans and chimpanzees is only 1%. The DNA difference. Remember DNA, the sequence of DNA? The DNA difference between us and the chimpanzees is just 1%. 99% of the DNA is identical. Remember, we did the table in DNA about this. That's what we are saying here. 1%, huh? Sepo? You like?
Yes.
You like that one?
I like that one.
That's good. Sepo likes it. I'm hoping the rest of you like it as
yes.
well. Okay, so those are some of the light-hearted debates around evolution. Let's go to the actual story now. What do scientists say? So where exactly do scientists place us, in other words? Where do we fit into this whole thing? Remember, you studied classification in grade 11, and you discussed the kingdom Plantae, plant kingdom, and you looked at the animal kingdom, etc. So the animal kingdom is where we're going to get our point of departure. Is divided into invertebrates, those without a vertebral column, backbone, and those with a vertebral column, the backbone. These vertebrates, as you studied last year, were divided into fish, frog, bird, reptiles, and mammals. And among the mammals, we have one of the orders under mammals is the order primates. So we're taking that order primates and we're expanding on that because that is where we belong. And what happens there now? Under this order primates, we have the suborder Prosimidae, and the other suborder Anthropoidea. Here we have the tarsiers and the lemurs, etc., falling there. That's not where we are. So we're not there. We are here in the suborder Anthropoidea. Under that, we have the Hylobatidae, the gibbons. We have the Pongidae, the orangutans, gorillas. Sepo, you with me?
Yes,
and the chimps. Look at this suborder Anthropoidea, the family Pongidae. We have the orangutans, the gorillas, and the chimps. And then we have the family Hominidae. And under this family, that's where we come. So, Sepo, to answer your question or to get back to your comment earlier, where you said that the chimp could be our ancestor.
Yes.
No, evolution is not saying that. What evolution is saying is that the chimp and the human share common ancestors.
Wow. Okay. Yes.
So, in other words, we are on the same line of development. We are different branch in one family.
Okay.
Eh?
Yes.
Now,
I'm with you.
Mashlangu's son is Obed. Mashlangu's other son is Josiah.
Josiah.
So you with Josiah, me, I'm with Obed.
Obed.
Okay. We are in different families.
Wow. Wow.
Okay.
Okay.
Are we clear with that mindset? As I'm hoping that that makes that easy for you as well. Good. Going further, now here's what we call a phylogenetic tree showing the evolutionary path of humans and other primates. So as I was saying, Seppo, there we have the early prosimians. There, down there. And from there, all these different organisms developed. And notice there we are here, humans. And along that line are the chimps. We did not come from the branch of chimps. If we developed from chimpanzees, Seppo, then our line would have to come from the small red line.
Okay.
That means there would have been a chimps, and from there a branch would be us.
Wow.
But we are on this same line. There's our common ancestor somewhere there.
Yes.
Okay. And on that line, the chimps are one line, and we are on another developmental line.
Okay,
That's what we are saying. Now, guys, are we then closer related to the chimpanzee or to the old world order monkeys? Obvious, right? Obvious. We are closer to the chimpanzee because we are on this branch. Whereas this branch divided a long time ago, and they're on a separate branch altogether. And we would be closer to the chimpanzee than the gorilla, than the orangutan, and the gibbon as well. Although we are all on the same line of development, our branch came closer to that of the chimpanzee than to any one of the others. So this is how you read this particular phylogenetic tree. You look at the closeness in terms of the line. They're going to ask you, so they can put A here. Okay, they can call this B, they can call this C, they can call this D, they can call this E if they want to. And they can ask you questions related to all of this. Where's this common ancestor? Which of these share a common ancestor, etc., etc., etc. You must be able to answer questions related to that. Good. Mindset is, I'm actually happy at the pace at which we are going without stressing at all. So, the first question says, and this is where we would obviously stop for a break after this, list the features that humans share with primates, those features that we have in common with the primates. And by the way, on here we have a figure 630 that shows apes moving through trees in a process called branchiation. And we're going to talk about that just now as we go along. So what is it that we share with them? We share bipedalism and the upright posture. I'm going to explain bipedalism after the break. We'll come back to that. We also share that the fact, now look what I'm done here, I'm going to one part of the body and then to the next, then to the next, then to the next, okay? We started with bipedalism and upright posture. Then we share that we have longer upper arms than legs. We share the fact that we have freely rotating arms, ball and socket joint. We share the point that we have elbow joints allowing this rotation there, this hinge joint here, and we also have this rotation ability there. We share the fact that we have bare fingertips, that our fingertips are not covered by anything. Don't let your nails cover that, then you fall in another group just now. We have opposable thumb. I can hold this pen nicely because the thumb and the fingers are working in opposite direction. We can clench a fist. We can grip something, so that gives us a power grip. All primates have larger brains compared to their body mass. This is in comparison to other organisms as well. The olfactory centers of the brain are reduced. Those areas that deal with smell, olfactory, are reduced in primates. So we have a reduced sense of smell. The parts of the brain that produce information from the hands and eyes, are enlarged. We have binocular vision, right? Seeing with two eyes. We have stereoscopic vision. This branchiation we're talking about, you can see height. If I stand on that table, I can jump down. Why? Because I know that there's a different levels there. If I didn't, I would just step down and fall down. We have eyes with cones, We have sexual dimorphism, that means separate, distinct differences between male and female. And we have only 2 mammary glands. Guys, that's a mouthful I have given you. With that, Seppo, take it to the break.
Okay, guys, I'm enjoying the show with Aslam here, and I see on Facebook you are interacting quite nicely, and I'm enjoying it. Now, remember to log into our into our website, which is landextra.co.za/live. And guys, remember to answer that question Islam challenged you with. Now we want to see who's really watching the show, who's a fan, guys. For now, let's take this quick ad break and see you after this. Welcome back, Mindsetters, and you're still here with me and Aslam. The show is going very great, and I'm watching on Facebook, guys. You are very active. Now, Islam, I have a question for you. The question is from Matume Tax. He says, "Is a mind of a human being bigger than an elephant?"
Matume's question, Belinda, I'm hoping you're listening to this question as well. And it intrigues me, that's why. And listen, I'm going to say it slowly and loud so you can hear it. The question Matume wants us to answer is the mind of the human, Belinda, is the mind of the human bigger than that of the elephant? Matume, answer. First of all, when you're talking of the mind, that's a deep question. We're not talking of the mind, we're talking of the brain. Remember that. The mind, we don't know whose mind is bigger. Mind is an abstract thought. We're talking of the size of the brain or the size of the skull. In comparison, and remember what we're saying, in comparison to the body. In the case of all primates, including the chimpanzees and the orangutans and all that, the size of the brain or the skull capacity is larger in comparison to the body than all other animals. I was going to say other elephants. All other animals, including the elephant. Remember, you are making a comparison between the size of the head, not the head as such, but size of the brain. Let's keep it to the brain. Size of the brain compared to the rest of the body. And as you would have learned, from the time you started, you went to the planaria, you went to the hydra, you went to the earthworm, the locust, the fish, the frog, the bird, the lizard. As you went up all of those organisms, you saw that there was a progressive increase in the size of the brain compared to the body mass. So that's what we are talking about. And the mind, Machume, don't talk about the mind because that's very deep. You've got to talk about physical things. The brain is what we're talking about. Anything else?
Okay, guys, there are no more questions.
Okay,
you can carry on.
Good. Now, just to recap what we spoke about, we're saying that we share this. There was another question that I saw earlier. Do we share similar traits or characteristics with the chimpanzees? Yes, that's what we are talking about, because chimpanzees are primates, we are primates, and these are the characteristics or traits. Traits meaning trays, not the ones that you're serving your food with. Trays, T-R-I-T-S, trays, characteristics. So we are saying that these are the characteristics we share with the primates. What are they? Bipedalism and upright posture. What is bipedalism? Bipedalism, bipedal, pedal, walking. So bipedalism, not walking. Pedal doesn't mean walking. Well, it would lead to the feet or walking. Bipedal, walking on 2 feet, like that. Walking on 2 feet. We are not walking on 4s. We are not walking on 4s. We're not walking on 4s. And I'm not talking about the fact when you are having some fun at home and you're running around on your foot. But that's not the way we normally walk. When we talk about the way we walk normally. Bipedal. So how does this happen? The whole thing about bipedalism is linked to the position of the foramen magnum, grade 10, grade 11 work. Foramen magnum, that hole at the base of the skull, which allows for the vertebral column to fit in. Now, imagine this is the head, okay? If this is the head, and if the foramen magnum is more forward, that means the hole is there, then it comes from the bottom up. It forces us to be vertical. But if the foramen magnum is at the back, and this is coming that way, it forces you downwards. It makes you horizontal, quadrupedal. Bipedal or quadru on 4. Okay? So that's what we are talking about. So think about what I said about the foramen magnum and the vertebral column. If it is more forward in the center, pushes upwards, vertical. If it's more on a backward, it's coming horizontally. The vertebral column is coming horizontally, forcing you to be quadruped. Okay, freely rotating arms, and we spoke about all of that. All of those guys we've spoken about. I'm not going to go into any explanations there. Good. Just for the benefit for all of those who do not remember the question that I asked. The question I'm asking is very simple. Last week, Wednesday, in the last 5 minutes of the show, I'm actually narrowing it now. And now I can just watch you all going and you're forwarding on the YouTube and you're going to the last 5 minutes. But that means you still have to listen again, so that's good. Last 5 minutes, there was something about HIV, viruses, and something else. Not necessarily HIV, not necessarily virus, but something I said that is definitely wrong, incorrect, and I will correct it at the end of this segment. I'm going to wait for your responses first. Good. We're moving on, and the question again. Notice that the answers to the question is the concept. What was the concept? Concept was similarities between us and primates. What's the next concept? The next concept is tabulate. First of all, the verb tabulate, so you have to make a table. What must you tabulate? The differences between humans and other primates. Notice, week after week I do this. I circle certain words, I underline certain words. What are those words? Those are the important key concepts, key words in the question. You need to do that. Not always physically, mentally also. When you look at a question, look for that. Look for the verb. That's the verb, tabulate. Whatever comes after the verb is what you need to do. What do you need to do? Tabulate the differences between humans and other primates. By the way, there's a lovely picture here showing you those big canines that we talk about. And we're going to discuss that as we go along. All this is in the textbook. That is the company that sponsors us, Macmillan sponsors us, and that's where we're getting that from. Okay, now let's look at the answer. Notice, guys, this is the way you should study. Look at a question, try and answer that question. The answer to that question should be your study note. That's the content. But don't look at the question, look at the answer and answer it. No, look at the question, answer the question, use a source to mark it, even if it's your textbook, and then change the answer to make it correct in another color, and that is your note. As you're going along, you'll develop more notes. So what are these differences? Okay, we start there. First of all, Homo sapiens has a larger cranium and the other primates have a smaller cranium. But now you're going to say, what the hell's wrong with you, Aslam? Just now you told us all primates have a larger brain. And we spoke to Matume about that as well. Yes, all primates have a larger brain, but the humans have larger than all the primates. Whether we use that brain in the right way or not, that's another story. Okay? What else? The face in the humans is slopey. And in other primates, it is a flat face. No, that's wrong, completely wrong. We have a flat face. We have a flat face. That would have been another mistake I made today. We have a flat face. And in the other primates, it is sloping. We'll talk about that just now when we get some other situation answers there as well. So be careful with that one. The brow ridges in humans are not pronounced. Our brow ridges are not pronounced. They're not protruding outwards. And in my case, because I don't have hair, maybe I look like one of the other primates. Forgive me for that today. Huh? Okay? The other primates, the brow ridges are pronounced. You see, this is also this is also wrong, okay? This is there. Sorry about this, guys, my typing errors. This is less protruding and not prognathous. This is more protruding. Today I'm sharper than last week. And the word is, I'm going to write it here, prognathous. Okay? Good. We are correcting our mistakes as we're going along. So imagine, even in memos, we can make mistakes, so you better be careful. Don't just look at it. We have a well-developed chin. And because of my hair extension piece here, my fake hair at the bottom, I can't show you my well-developed chin. Seppo, you can show them your well-developed chin. Huh?
I hope you can see it.
All right. All right, we spoke about smaller canines in Homo sapiens, and there's the larger canines there. Oops, I'm going to move that guy out again. Smaller canines, larger canines. That's straightforward. The teeth in a human are the jaw in a gentle curve, a roundish curve, whereas in the primates, it's in more of a U shape, as you can see clearly here. Let's just do that and see if I can do that there. Can you see there? Rectangular or U shape. Physically, there's an example. You don't have to imagine it. Here's an example. This guy's got his jaw wide open, and you can actually see the U shape or the rectangular shape there. And in our case, our jaw is more in a gentle slope like that. Good? Very good. Oops. There. And we spoke about earlier, the foramen magnum in our case is at the bottom of the skull. Bottom and more, this is also wrong. Wow, I've made a lot of mistakes in the typing. In a more forward position. And here in a more backward. We'll take that out. The bottom of the skull, but more forward position. And this more forward position makes it bipedal. And here it makes it quadruped. Now, in the case of the other primates, they are more quadruped. They have the ability. Remember we said similarities, bipedalism. Yes, they have the ability to be bipedal. But most of the time they are quadrupeds. Most of the time we are bipedal. Sometimes we will mess around and we can use our hands to crawl and the rest of it. Okay? That's the differences between us and the other primates. Remember when you're getting marks here, what would happen is 1 mark you get for the table and 1 for each difference. And your differences must be next to each other. And that's how you get your marks here. Please make sure that you correct what was incorrect originally. Flat face in humans, sloping in the other organisms. Less protruding jaws in other primates. Prognathous is the word. And forward position of the foramen magnum in humans and a backward position of the foramen magnum in other organisms. Be careful with that. You could make that mistake as you're going along, switching the tables. Good. So guys, what have we done so far? Let's just do a quick audit in terms of what we're saying in terms of this work that we are doing now. First of all, we are always bipedal. So that's the difference between us and the other primates. We have a flat face. We are not prognathous. That's an A there, right? Prognathous. Our dentition, round, gentle. We have smaller canines, or rather, sorry, dentition is the dental formula, okay? Jaws on a gentle curve. A larger, I won't say large, but a larger brain. And finally, we didn't say it in the table, we also have the ability of artificial language, like I'm talking to you in English. And we can talk in Xhosa, we can talk in Pedi, we can talk in Afrikaans, we can talk in Greek, French, etc. So we're saying that the other primates, they do not have this artificial language. I wonder sometimes, Seppo, however, if we are in France and we have a whale in the water, does that whale communicate with other whales in French?
I don't know about that.
Eh?
I don't know about that.
I wonder. We'll have to do some research. Maybe
Yes,
you do your doctorate on that thesis. Show that the ones in India, they speak Gujarati or Urdu, and the ones in Arabia, they speak Arabic, and the ones in South Africa, they are confused because there are, how many languages we have?
11 languages.
11, that's a lot of languages.
Yes.
They are confused. So they're going to have a problem. Eh?
Yes.
Okay. Good. Let's move on. Now, we spoke about the development, or rather the discovery of different fossils all over that leads to this understanding of evolution. And here we have some diagrams showing you the Australopithecines. I got it right one time, Belinda. There we go. I shouldn't have said that. Australopithecines. There we go. I got it right twice in one day. And their brain capacity was between 400 and 530 milliliters or cc there. Homo erectus had a brain capacity of 775 to 975 cc, And Homo sapiens has a brain capacity of 1200 to 1600 cc, on average 1400 cc that we have the brain capacity. So we can see clearly as we are moving from the earlier hominids, Australopithecines are the first hominids. Moving from that to that, there's an increase for Homo erectus, increase in brain capacity, and from there to humans, there's a further increase in brain capacity. So that's one of the difference. The less sloping face is the other development as we move on. The rounder jawline, the teeth, and the smaller canines, the less gaps between the teeth. These are all developments as we move from the earlier hominids till Homo sapiens. That's us. With that, we take the break.
Okay, guys, thank you guys for the questions that you are asking on Facebook. And guys, one other thing I forgot to mention is the Future Stars competition. Please, if you believe in yourself and you believe that education can change your future, please enter the competition and ask your friends to vote for you, and you'll be walking away with awesome prizes worth 10,000 rands. Now, what would you do with that, guys? I hope you're gonna enjoy it. But for now, let's take a quick ad break and see you after this. Welcome back, guys. I hope you had an awesome break. You had that glass of water. Now we're continuing with evolution. Now, a lot of information is being overloaded with us here. Now, Aslam, I have a question.
Yep.
A question is from Herim Tembu.
Harry.
Yeah, he says, what advantages does an upright posture give to a primate?
Harry, what a lovely question. He wants to know what advantages does an upright posture give to a primate, or humans for that matter. Okay, I'm going to now go down on fours for you. I'm going to go into the crawling position, okay? Okay, I'm on the floor. Now, the camera can't pick me up, isn't it? Now imagine what I can pick up when I'm crawling then. That means my view of the world is limited. Now, the minute I'm upright, now think of an organism that is in the bushveld where there's lots of grass. Now, if that organism were to be upright, they get a wider view of the things around them. Okay, so that is the main advantage of this upright posture. In some primates, the upright posture, believe it or not, Belinda and Seppo, in some primates, not in males, not in human males, but in some primates, the upright posture gives the male the advantage of displaying his genitalia to females. Okay. So he spreads out to show his private parts, so females get attracted to his private parts. Wow. Right? That's something to think about.
Yes.
Right? So just watch the way you walk in the mall next time. Not a good thing to walk that way. So those are some of the things. Also, in us, in human beings, it frees our hands. So in other words, I can carry this pen. A mother can carry her baby. We can carry our shopping. So it frees the hands to do other things while we are walking. Imagine you had to be on fours. Now, how are you going to carry and pick up things and walk at the same time? They were complicated. So those are the advantages that we can talk about there. So we were talking earlier before the break on the development of this. So we're moving on from there. And now we're just going to do a little bit of, what can I call, a timeline. Not on a line though, but in terms of a chronological sequence of what has happened. The first species of Australopithecines were the Australopithecus afarensis, from afar, 4,2 to 2,5 million. You'll notice, Seppo, when we're talking about here, normally I say 5 to 10 or 2 to 10. Here, when we're talking about millions of years in terms of geological time, we give the bigger number first, because 4,2 million years ago is older than 2,5 million. Yes. So when we're saying that, we're going to the back first and we're coming to the front. So between 4,2 and 2,5 million years ago were the first Australopithecines. According to the dating, remember last week we spoke about absolute dating and relative dating of fossils. Based on that information, this is what they say. Okay, one of them was Lucy, found in Ethiopia. Okay, Lucy. By the way, just an interesting thing: the fossils named Lucy was given this name because at that time Beatles has the group Beatles had a song with Lucy in it, the title, and that's where Lucy got that. These guys, when they discovered this fossil, they started singing the song Lucy in around the fire, and that's how they gave the name Lucy. So don't think that there's a general rule. It depends who discovers them, what is their mood, how they want to call it, etc. at the time. Next guy was Australopithecus africanus, obviously from Africa, also closer, when 3,5 to 2,5 million years ago. And among these are the famous fossils that were found in South Africa. And what were those fossils? Taung child, found obviously near Taung, near Kimberley. Mrs. Pless, which now is called Mr. Pless also. Sterkfontein caves. You can do some research on why Mr. Pless is now called Mr. Pless. Littlefoot, also in the Sterkfontein caves. And more recently, 2010, World Cup, Karabo, also found in the Sterkfontein caves. So you can see this area here, rich with hominid fossils. This is why when you go to Maropeng, it's called the cradle of humankind. And we're going to discuss some questions relating to cradle of humankind just now. And that's what we're having there. Next was Homo habilis, 2 to 1,6 million years ago. After that, came across our friend Homo erectus, 1,9 to 0,3 million years ago. Then came Homo neanderthalensis, okay, Germany, in that around Germany area, okay. Then we came onto the scene, Homo sapiens, okay. If you look at your timelines, as we'll see later, here's 1 year right in front of us, a quick one here. I'm going to just not go through all, but here we have your Homo erectus in that time zone there. You also have your Heidelberg Genesis and the Neanderthalensis also in that area, and Homo sapiens. Now this would tell you that all of these were in more or less the same time period. However, these guys are still around and these guys are not around anymore. That means Homo sapiens outcompeted the other two. Natural selection favored us, and therefore we are more successful. We were more suited to the environment according to this scientist theory. We were more suited, and therefore that is why we are here and they are extinct. All of the rest of them did not survive, and it went on that way. Okay, so this is a nice graph on a timeline to show you the development. Okay. Okay, here's something a little clearer in certain ways. Again, a timeline just showing you all the different Australopithecus around there, Robustus, habilis, we got your Gari, erectus. And notice now how science develops. Science is not static. Science develops over time, and if there's something that they find that's something wrong, then they're going to have to prove it to the science world, and then the changes will be made. Notice this one in red. It's been added there. Australopithecus sediba. This is Karabo, that was found by Lee Berger, the son, Professor Berger's son, found it in Kromdraai around the Sterkfontein caves in 2010. And can you see where it's fitting in? So they're trying to say that that could be the missing link around there between Homo erectus and Homo sapiens, etc. So they're trying to put that in there. And this is what happens. This is what science is dynamic. There's no fixed. Science is not fact. Science is based on theory. This theory can be disproved or proved depending on the evidence at the time. So this one has been stuck in there to show that. And some little bit more real life. Obviously, it's the artist's impression of Homo erectus, how he would have looked. And Boisei, Paranthropus boisei, the Afarensis, the Africanus, Anamensis, Rudolfensis, Homo habilis, Neanderthalensis, all of them, they're giving you the different one. And obviously, getting into this whole thing, I hope I don't affect the skin, Homo sapiens. Huh? Do I fit in there? No, I stand above all of that. Huh? No, I stand somewhere there in between. Good. Now we move on with questions, guys. We have covered most of the theory. We're moving on with the questions. Diagrams A, B, and C taken from November 2011, the final paper, questions 3.1, 3.2 from paper 1. A reminder again from last week what we said, that the paper 1 from 2011 onwards, evolution is found in that paper, and evolution is found in prior to 2011, 2010, 29, 28. We have evolution in paper 2, and also in your version 2, 2011, version 2, 2012, the evolution falls in paper 1, in paper 2 as well, because that's the old version. I've been told today, I've received email saying, I'm waiting for an official letter, that at the end of this year, there's only one paper. Whether you wrote in 28, 29, 2010, and you are rewriting, doesn't make a difference. At the end of this year, there's only going to be one version of the paper. So this is the email that I received today, I was this morning, actually. So they're saying here, A, B, and C below illustrate the skulls of Homo sapiens, Homo erectus, and Pan troglodytes, a chimpanzee. The diagrams are drawn to scale. There we have A, B, and C. The question asks, which diagram, A, B, or C, appeared last on Earth according to scientists? Now we've got to understand these things. Firstly, guys, look at the sloping of the skulls. Remember what we said, that as we move in time, the sloping became less and less and less. Look at this guy, there's the slope. Look at this guy, there's his slope. And look at this guy, there's his slope. So this guy obviously seems to have the biggest slope there. This guy a little bit less, and this guy the least sloping. And you can identify with an X-ray that this will look more or less like yourself. So the answer would be B. And if they ask you to name it, it would be Homo sapiens. Tabulate three visible differences between diagram A and diagram B that illustrate evolutionary trends in human development. So we are looking at diagram A and diagram B. That is your, obviously would be the Homo erectus and Homo sapiens, and they want to know the differences. So let's look at those differences. First of all, Homo erectus has a smaller cranium or brain. Homo sapiens has a larger brain. Homo sapiens, less rounded cranium, skull is flatter. Remember here, they're asking for observable difference, what you can see only. So you can't list everything that you know. More rounded cranium or skull. Let's go back to the diagrams. You can see rounder, this one is flatter. Huh? Prognathus, I showed you that already. Prognathus, not prognathus. No obvious chin, pronounced chin in the human one. The eyebrow ridges are visible. There you go. There's your, oops, I forget about that. The eyebrow ridges are visible. Let me just do a bit of an undo quickly. Okay, your eyebrow ridges are visible there, and here they're not so visible, as you can see. Good. And go back to that guy. Eyes are facing forward, eyes to the side. A more developed cheekbone, less developed cheekbone, and a bigger lower jaw, a slightly smaller lower jaw. These are what you can see in the diagram. Okay, this is now a revision of what we have done. That one was generally what's the difference. This one says, look at this diagram and answer the question. What you have to do is look at the visible differences. And lots of learners, when they see these things, they'll tell you that there's 3 lines here and there's 1 line here and so on. When we're talking about these visible differences, we are talking about visible differences that illustrate, I forget about that thing. Okay, that illustrate the evolutionary development. So you can't talk about lines and no lines and all that type of nonsense. You got to talk about what is happening in terms of evolution. Those things that we learned, apply it to where we are now. Okay, we still with that. They're saying now, describe 2 lines of evidence which support the idea that human population had its origins on the African continent. But that statement on its own actually says out of Africa hypothesis. Out of Africa hypothesis states that the human population started in Africa and migrated out to other parts of the world. Multi-regional theory would say that the human population started all over the world and they migrated in different directions. We from South Africa, so we are punting this one here, the out of Africa hypothesis. But here they're not asking about what it means. They're asking you what evidence will support. If I say humans started in Africa, what can I support that with? How would a scientist support that? Let's look at that quickly. First of all, the oldest fossils, the Australopithecines, for example, Homo habilis, have only been found in Africa. Okay? That's one. The oldest fossils of Homo erectus have also been found only in Africa. And these are the other things that we must talk about. The analysis of mitochondrial DNA shows that the oldest female ancestors of humans are from Africa. Mitochondrial DNA is DNA that's found in the mitochondria, not in the nucleus. This mitochondrial DNA is donated, or rather is passed on, not donated, that's not a good word, is passed on from parent to offspring, from the egg. And where does the egg come from? It comes from the mother. So mitochondrial DNA shows female ancestry. And one such female was traced back to Africa, which is called the African Eve. And that is saying that the oldest female ancestors of humans are from Africa. Analysis of the Y chromosomes shows that the oldest male ancestors also of humans are from Africa. Again, the Y chromosome. What is the Y chromosome? We did meiosis. We spoke about sex chromosomes in genetics as well. Sex chromosomes are either X or Y. The Y chromosome is only found in males. And if the male only transferred that Y chromosome to his sons. So by following Y chromosome mutations or whatever characteristics are found on the Y chromosome, we can trace male ancestry. And by doing that, scientists have traced one such male ancestor to be the oldest in Africa. So therefore, this is supporting the theory of out of Africa hypothesis. So that's your evidence. There we have it. One is fossil evidence. Yeah. Oops. Fossil evidence. Yeah. And DNA evidence. That's your 2 lines of evidence. One is fossil. The oldest fossils, one mark, fossils were found in Africa. And you can give examples. Sometimes they give you 3 marks. Then you can give examples of any of the Australopithecines. The other one is DNA. DNA, there's 2 types. This one here, DNA there, and the analysis of DNA on the Y chromosomes. That will tell us that's the second line of evidence. So the 2 lines of evidence according to the syllabus, 1, 2. That's what you have to talk about. Good? Now, this question is a little bit long, so we're going to go through it very slowly. The percentages of female Anopheles mosquitoes that were resistant to an insecticide each year are shown in Table 4. In 2000, there was a maximum number of resistant mosquitoes. The other numbers are percentages of the maximum. So by the time we got to 2000, we had the highest resistant mosquitoes there to insecticides. And anything else is a percentage of that maximum. Here's the maximum number. These are the percentages of it. So in 1996, there were only 4% resistant to that maximum number. 25, 50, 90. Can we see there's a progressive increase as we go from the left, or from 96 to 2000? A new insecticide was used in 96 and killed most of the mosquitoes. Only 4% of the mosquitoes had resistance. So 4% of them survived. Explain why the number of mosquitoes resistant to the insecticide increased annually. Use natural selection to answer that question. All right, so you see we're experimenting on different things at the moment. First of all, now this is the crux of this. This is evolution in present time. So we covered out of Africa, now we're covering evolution in present time. So guys, you have lost nothing. You've done the whole syllabus of evolution by way of questions now. Okay? So what happens? Number of mosquitoes increased annually owing to reproduction and survival of greater numbers of resistant mosquitoes. So in other words, initially the 4% were only resistant. But what happened is these resistant ones started reproducing. So in other words, they had a favorable condition. Then the insecticide was killing the others. But these guys survived, and because they survived, they could reproduce. So when they sprayed again, more of these guys were produced, and therefore they survived over time. And over several generations, when we came to the maximum number in 2000, there were more resistant ones and less of the non-resistant ones. Why? Because the frequency of those that are resistant increased and the frequency of those that were not. In other words, our points: overpopulation, variation, competition, successful, survival of the fittest, natural selection. You must answer that in that whole question there. I'm only going to do that there, and we go last to this question here. What happens to the non-resistant mosquitoes in 1996? In 1996, most of the mosquitoes were not resistant to the insecticide and they died. Go back to your table. Why? Because only 4%. The others all died. Good? Simple question there. Next one, 1997, there were few non-resistant mosquitoes, or a lot, and explain why. There were a lot of non-resistant mosquitoes in 1997 because the resistant mosquitoes had only been breeding for 1 year. It was still early, so there was still more of the non-resistant ones. Do mosquitoes resistant to insecticides carry the malaria parasite? And obviously some mosquitoes carry malaria parasites whether they are resistant or not. Right, now, quickly, that question. Anybody gave us anything?
No.
Nothing. Guys, last week we were talking about viruses and bacteria, and then I switched all of a sudden to TB, and I said that TB is caused by a virus. No, TB is not caused by a virus. So none of you are winners today. I would have given you a free lesson, or have given you $10 or $20, but none of you came with the answer. And I'm going to do this every week. I'm going to give you a question of my own, and we'll work something out between the two of us. But in the meanwhile, none of you had it. I said TB is caused by a virus. TB is not caused by a virus, caused by a bacteria. With that, guys, I hand you to Seppo.
Guys, I enjoyed you guys on Facebook. I enjoyed your cooperation, and I hope you also enjoyed I hope you also enjoyed our life sciences, guys. Guys, my name is Telpo, and I enjoyed the show, guys. And I thank you for helping me out, and I help you for helping each other out on the page, guys. Please, next week, same time, same place. See you.
Penalized for believing or not believing in that and changing your religious beliefs. Okay, so let's get the show rocking. What do we do today? First of all, we're going to consider those aspects of human evolution as follows. We want to see a phylogenetic tree. Remember, we spoke about phylogenetic tree already in DNA, and we spoke about it before, a phylogenetic tree, commonly called family tree. Remember in the exam, when they ask you this question as a terminology question, you cannot write family tree. It is not accepted. All right? This is a phylogenetic tree to show ancestry, not just who your grandparents are, but to show ancestry in terms of the origin of species. That's what we use a phylogenetic tree for. And why we're using it here is to show our place in the animal kingdom? Where do we fit into this whole picture, according to scientists? Also, we go a little further to see what characteristics we share with other primates. And we go further to see what makes us different, what makes us unique from others. We then want to see progressive evolution of these features that we are talking about, the similarities and the differences. Progressive features, what the hell does that mean? It means, according to evolution, things started primitive and became modern. So progressive would mean from the oldest to the current. What happened? How did these changes, or what changes took place as such? That's what we are talking about there. And the contribution of African fossils, mainly. We look at a lot of fossils, but our concentration is more on those fossils that were found in. You like?
Yes.
You like that one?
I like that one.
That's good. Seppo likes it. I'm hoping the rest of you like it as
Yes.
well. Okay, so those are some of the light-hearted debates around evolution. Let's go to the actual story now. What do scientists say? So where exactly do scientists place us, in other words? Where do we fit into this whole thing? Remember, you studied classification in grade 11, and you discussed the kingdom plantae, plant kingdom, and you looked at the animal kingdom, etc. So the animal kingdom is where we're going to get our point of departure. Is divided into invertebrates, those without a vertebral column, backbone, and those with a vertebral column, the backbone. These vertebrates, as you studied last year, were divided into fish, frog, bird, reptiles, and mammals. And among the mammals, we have one of the orders under mammals is the order primates. So we're taking that order primates and we're expanding on that because that is where we belong. And what happens there now? Under this order primates, we have the suborder Prosimidae, and the other suborder Anthropoidea. Here we have the tarsiers and the lemurs, etc., falling there. That's not where we are. So we're not there. We are here in the suborder Anthropoidea. Under that, we have the Hylobatidae, the gibbons. We have the Pongidae, the orangutans, gorillas. Seppo, you with me?
Yes,
and the chimps. Look at this suborder Anthropoideae, the family Pongidae. We have the orangutans, the gorillas, and the chimps. And then we in Africa to the understanding of human evolution. In other words, we found these fossils here. Good. So, scientists are saying, we found these fossils here, and this is what it means in evolution. Where do these things fit in? Jigsaw puzzle. You're busy fitting the parts together. You can't just put any piece anywhere. You've got to put the pieces that fit into each other together to make this big concept, the puzzle itself. So the same thing we're talking about here. Fragments. A fossil was found in Tanzania. A fossil was found in Ethiopia. A fossil was found in South Africa. Kromdraai, etc. Taung. Everywhere fossils were found. But how do these fossils increase or decrease the scientists' understanding of the development of humans? Then we go to what is called the out of Africa hypothesis. And we're also trying to, if we get that far, to discuss evolution in present times. Now, at this juncture, I want to pause. And I'm going to ask a question. And I want you to pose this, the answer, post. I'm posing the question. You must post the answer on the Facebook page. I want to know from you, and I want to see who's the person that answers first. We're going to announce your name here on the show. Last week, right at the end of the show, I made a very big mistake. Not so big, but it's a mistake nonetheless. I'll give you a hint. We were talking about natural selections, and we were talking about viruses. Okay, so HIV was the question that was posed to me. All right, I want you to figure out if you remembered from last week already, if you were watching last week. So I'm checking whether you're watching on one hand, and at the other hand, I'm checking whether.
Hello, hi, grade 12s. How are you? A little baby tells me that you have been waiting anxiously for this show. Now, today we are doing life sciences and it's 6 p.m. and we are doing life sciences. Hope you're going to enjoy the show. Hope you got all your pens and papers ready for the show. And remember to visit our website, which is landextra.co.za/live. Or simply go to our Facebook page, which is facebook.com/landextra, and like our page. If you didn't like it yet, where have you been? And for those who have been in a page with us, you know what to do. Ask those questions, those queries, and help each other out on the page. Now, helping us on this today's show is the awesome life science guru. It's Islam. How are you? Aslam, how are you, sir?
Are you, Seppo, I'm fine. Are you using the word guru because I'm Indian?
No, because
sure.
I respect
Otherwise
you.
I'll call you racist.
I'm sorry. That's Aslam himself, guys. You know him.
Hi, guys.
Okay, guys, enjoy the show.
Welcome to Mindset Live Extra, guys. And we have extra today. We have Seppo with us. And I'm hoping you are energized and ready to rock and roll. We come to the most controversial part of evolution, and that is human evolution. But remember, when we started evolution, I told you that we are learning evolution as a theory. Nobody's asking you to change your belief, and not even the examiners are asking you to change your belief. When you are writing about what the scientists say about evolution, and not whether you believe it or not. Nobody's going to ask you also. You cannot be whether you are sharp enough. I picked it up the minute I left studio, and unfortunate part is I can't rewind. I can only do it the next week. So I'm going to correct that today. But I'm going to leave that till the next session. That means after break, I'm going to check what you tell us, and we'll take it from there. Lastly, if we can, we'll consider alternative explanations to evolution. In other words, the creationist theory and the intelligent design as explanations. We also can look at arguments against evolution if we have time. But otherwise, we will do that when we do revision. The question now is this guy your ancestor? Seppo, is that your ancestor? You think? Grandfather, great-grandfather?
Great-great-great-grandfather.
You think so?
Yes, I think
all right. One we finished today.
Yes.
You're going to tell me in the last segment whether you agree with the statement you're making now. Seppo is telling us that he agrees that this could be his great-great-great-grandfather because it's one of our ancestors, according to Seppo. But I want you to listen carefully, Seppo, and you tell me at the end of this show today whether you agree with that statement or not.
Okay, I'm with you on that.
You're going to tell me, right?
Yes.
Okay, in some... There, Seppo,
Yeah.
a little better view.
Yes.
Huh? Or are we there?
Oh my word.
Striking similarities, don't you think, guys? Huh? The DNA difference, Seppo, between humans and chimpanzees is only 1%. The DNA difference. Remember DNA, the sequence of DNA? The DNA difference between us and the chimpanzees is just 1%. 99% of the DNA is identical. Remember, we did the table in DNA about this. That's what we are saying here. 1%, huh? Seppo?